Alright, so in this video, I'm going to generate a sample design using Vivado 2022.1 and the Arty Z7-20 starter board. So the first thing we're going to do is we're going to create a project. This is my work area. I'm going to name this project DMA Test 2022.1. I'm going to click Next. I'm not going to specify any sources. I'm going to pick the board. So I'm going to type Arty Z7-20. As you can see, I have version 1.1 of the drivers installed. Click Next, Finish. Okay, so now I'm going to create a block design. I'm going to leave it with a default name. It keeps things simpler when you do that. I'm going to click the plus button. I'm going to type ZYNQ. Alright, now that the ZYNQ IP has been added, I'm going to run block automation. Defaults are fine here. Now I'm going to add two DMA controllers. So I type DMA in the search. It's the second one, AXI Direct Memory Access. Let me make this window bigger. Now I'm going to add another one. You can cut and paste, but I don't know. For the video, I'll just do it manually. Next, I double click on the DMA controller and I'm going to configure it. So I'm going to disable control status stream. I'm going to modify the stream data width to be 64. This will also make the memory map data width to be 64. And I'm going to do the same thing for the right channel. So I'm going to uncheck auto, select 64. And as you can see, it's same for the memory map data width. Now I'm going to click on the other DMA controller. I'm going to disable control status stream, set the stream data width to 64 for both the write and read channels. Now I'm going to run connection automation, defaults for everything. As you can see, both DMA controllers go to one AXI interconnect that is connected to the GP0 channel of the ZYNQ processing system. Now I'm going to add two AXI 4 stream data FIFOs, which I'll connect to the DMA controllers. This time I'll cut and paste. So I just press Control C, Control V. Now I'm going to modify this. I'm going to modify the T data width to be 8 bytes because we want to do 64-bit. Same thing for the other DMA FIFO. I'm sorry, for the AXI Stream Data FIFO. Now what I'm going to do here is that the slave interface for a FIFO will be written to the master of the DMA channel. The M master axis, the M underscore axis stands for master axis, and MM2S stands for memory mapped to stream. So I'm going to connect this read interface to one FIFO and the write interface to the other DMA. Same thing for the second FIFO. Ooh, undo that. All right, here we go. Wrong pin. There we go. So now I can click Run Connection Automation again. It's just going to connect the clocks. Okay, so we have two DMA controllers, two AXI 4 stream data FIFOs connected. Now I want to add, let's see. We have to connect these pins. That's the scatter gather or SG, MM2S and S2MM, which is for connecting to the AXI interconnect. So to do this, we have to go to the ZYNQ processing system. We have to go to PSPL configuration, select the HP slave AXI interface, and enable interface 0. We're also going to need interrupt support. So we're going to click Fabric Interrupts. We're going to enable IRQ F2P for the PL to PS interrupt ports. That's programming layer to processing system interrupt ports. So now if I click connection automation, you will see that AXI HP0 will get connected to a brand new interconnect that connects to one of the AXI DMA ports. Now we have to click run connection automation again, and it'll do the rest of them for both DMA controllers. As you can see, scroll to the right, look, 4, 5, and 6. So now that we have that, we want to add a regular FIFO. So we're going to click add IP. We're going to type AXI Stream FIFO. Again, we're going to copy paste, and we're going to configure both FIFOs. We're going to disable transmit control, interface to AXI 4 data width to 64. We're going to do this for both FIFOs, disable transmit control, set data interface to AXI 4, and AXI 4 data width to 64. Then we can run connection automation, and it'll go to the original AXI interconnect. So what do I mean by that? Look at these two ports. They go to this AXI interconnect, and this should connect to the GP0 of the ZYNQ. Now HP0 goes to the DMA controller. So now that this is done, we have to connect the interrupts. So we're going to add a concat IP. We're going to modify it. We're going to say to have 6 ports. First thing we're going to do is we're going to connect the stream FIFO interrupts, and then we're going to connect the DMA interrupts. So we're going to take MM2S, S2MM, MM2S again, and finally we're going to have to take this output and plug it into the IRQ. Now we forgot to connect the two FIFOs. What we're going to do is we're going to connect the transmit of one to the receive of the other, transmit of the other to the receive of the first one. So now this design is ready. I'm going to save it. I'm going to, what does that say? Regenerate layout. So nice and prettier. I'm going to click validate design. Should take a couple more seconds. This is always quick. I'm going to go to sources. I'm going to create an HDL wrapper, and I'm going to let Vivado manage and auto update it. After this is done, I'm going to right click on the design and say generate output products. This can take a little bit more time, so I'm going to stop the video here. So now that it's finished, I'm going to click OK. And now I'm going to go to the bottom. I'm going to say generate bitstream. This will take care of running synthesis and implementation for you. This should take a lot longer, so I'm going to stop the video again. Okay, so now bitstream generation has completed. We can click cancel here, and now what we're going to do is we're going to export the bitstream to, we're going to export hardware. Hardware, we can also say include bitstream, and we're going to do this so that we can generate a project in Vivado Vitis. So I'm going to click next, finish. Now, if we go to the source code, well, where the source code is located, let me refresh. This was just generated, DMA test 2022.1. If I go into this directory, you will see an XSA file generated just now. It's March 10th, 2025, 2:03 p.m. Now I'm going to create a directory. I'm going to name it SDK. This is only because I used to use Vivado SDK, which has now been renamed to Vitis SDK. So now I'm going to start Xilinx Vitis 2022.1, and I'm going to set that to the root directory of the project. Let's see, DMA test 2022.1 SDK launch. Okay, let's bring Vitis into this window. Now the first thing I'm going to do is I'm going to create a new platform project. I'm just gonna name it plat, click next, and now it's gonna ask me for the XSA file. So I'm gonna click browse. I'm gonna go to the same folder that I was in before for the SDK. Then I'm gonna go up one directory, and there's the design1 wrapper.xsa file. Now I'm gonna click finish, and we're gonna have a new platform project. First thing I'm gonna do is build this project. It doesn't necessarily take a long time, especially on modern hardware, so we can wait. Okay, so now I'm going to create a new application project. I'm going to call it, first of all, we have to pick the platform, which should automatically be selected. I'm just going to say DMA test. Next, next, and hello world is fine. Finish. And now I'm going to open the hello world main function. This does something very simple. It just prints hello world. I'm going to build this project. Then I'm going to go to the debug workflow, and I'm going to click on the Vitis serial terminal. With the default PS7, that means it's using the Vitis 115200. So I'm going to connect to a serial port. I know already that it's COM10, but usually you'll just see one, and you can trial and error. So I'm connected to the ZYNQ board itself right now, the Arty Z7. I'm going to right click on the project and say debug as. While I wait, let me see if I can find the source code. There it is. We're going to use this source code in a bit, but for now let me minimize this. It is connecting to the ZYNQ hardware. It is launching the debugger. Alright, it usually breaks on the first line, so I just press F8 or click resume, and now let's see what happened. It ran. That's output from the previous application. Don't worry about that. So now I'm going to go back to the design view, and we have our application, right? So here is the new project, DMA Test 2022.1 SDK. I'm going to go into the DMA test folder, source, and I'm going to go to the other window where I have the previous project. So I'm going to take DMA test.cnh, hello world, and just copy it over. All right, so now if we click here, you can see DMA test and hello world. Now I'm going to rebuild this project. And actually, let me explain what it does. The first thing it does is that it writes to one of the FIFOs and it reads from the other. And if there are no errors and the data matches, it'll return 0, exercise FIFOs passed. Same thing for the DMA. If the response is not 0, DMA failed. So really quick, let's give this a run. Debug as, launch hardware. Let me make this window a little bit bigger. All right, let's see what's going on here. Launching debugger. All right, let's see. Uh-oh. It didn't stop in this program. Something's wrong. Let me run it again. Debug as. I think it's in the wrong file. I may have to do a clean build. Yeah, it's it thinks that's the first line of code. That does not make sense. So I'm gonna go back to the design view. I'm gonna clean this project. No, close all the windows. Might as well. All right. Now we're gonna build it. And we're gonna right click and say debug as launch hardware. All right, everything looks fine. We're gonna click resume, go to Vivado's terminal, and look at that, exercise DMA passed and exercise FIFOs passed. I have a lot of debugging output here. I'll clean it up, but basically I send a 64-bit value and I receive the same value from the other FIFO. I only print out the first number, but I do it for a lot more. So let's look at exercise FIFOs. We start FIFO 0, we start FIFO 1. Prepare the data. Notice that's 64 bits wide. We transmit using XIL out 64 because the current drivers with Vivado SDK do not include 64-bit versions. So here we use XIL out 64 with the data, but the data is itself a U64. Then we read, see, we transmit on FIFO 0. We wait for transmit to finish. Then we wait for data to arrive in FIFO 1. We get all the data and we store it. And we compare them over here. And then I just dump out the first one just so we know what happened. Now for exercise DMA, what happens is we have to pick memory base. Now this has to be in the general memory region of the ZYNQ processing system. And it has to be unique per DMA controller. So over here it's, let's count it out. 1, 2, 3, 4, 5, 6. So what is that? 1 million? Address location 1 million hex. We set up AXI DMA controller 0. Then I take that memory base and I add another million to it, set up AXI DMA 1. Then I prepare the data I'm going to send. Again, that beef with a bunch of numbers, 64-bit. I send the DMA packet on AXI Stream 0. Then I check for results on DMA channel 1. Then I do it again, but this time I send on channel 1 and I receive on channel 0. Now if you take the default code that comes with this driver, let me just drill down. You'll see that it sends the data. Well, first of all, again, first of all, here there is no XIL out 64. Here I'm just writing to a region of memory. I flush the memory, as was done in the example, to make sure there's no caching in the way. And what happens is that give the BMA to kick off. It does the transmission, and I wait for it to come back and say finished. There used to be something in here that would wait for a receive on the same channel. So I removed that for the purposes of this example. Anyway, you can see the source code. I'll link it below. Thank you.